All right, we're going to do problems 121 through 125 in your physics notebook. These problems tend to be challenging for people, but you need to have a really good grasp of what we're trying to do here. So it's really important that you understand the equation for a straight line graph. The equation for a straight line graph is y equals mx plus b. And we are going to spend all year trying to prove and validate various physics laws. And to do that, we're going to use graphs. And what we want to do is we want to graph things on the y and graph things on the x so that we end up getting a straight line relationship between those two variables. And then we can measure the slope and figure out something about the equation, some kind of a constant or something like that. So every equation that we have that we're going to try to validate, you need to get good at cramming it into the y equals mx plus b equation. So, and knowing what should be y, what should be x, and therefore what would be the slope. So this is challenging. It's going to take a little while to maybe figure out what we're doing here. But the number 21 says, for Newton's universal law of gravitation, okay, well, what's that? Well, back a page or so, we introduced that to you. The force between any two objects is a big constant g times the mass of one of the objects times the mass of the other object divided by the distance between them squared. This is how much force exists between any two objects. You might not have known that, but any two objects you pick, any two objects, doesn't matter how light they are, there's actually a gravitational force attraction between them. We're not really always sure exactly why, but it's mathematically, you can use this equation to actually calculate it. So it's big G, some universal constant, which you don't need to know right now, but it is on your equation sheet if you'd like to look it up, times mass of one of them in kilograms, times the mass of the other in kilograms, divided by the distance between them in meters squared. So this is called Newton's universal law, universal gravitational law. And we're going to learn a lot more about that later on when we get to forces. But right now, we're just using it as an example of how to cram it into the y equals mx plus b equation. So it says, using this law, what would you graph on the x-axis? And what would you graph on a y-axis? So that you would get a straight line, and the slope of that line would be equal to the universal constant g. You want the slope to be g. Okay, this first problem is pretty easy, because if you look at this, we can cram this right into the y equals mx plus b. We can say, all right, force, we'll have force be the y, okay? Force is the y, then we have the equal sign, and then we have big G, and we want that to be the slope, right? So there it is, equal with the m. So what should the x be? Well, x is going to be everything else, right? It'd be m1, m2 over d squared. Now, what about the y-intercept? Well, it's 0, and there's no y-intercept out here. So we can just do plus 0, okay? We can plug in a 0 for the y-intercept, and we have it. So what does this mean? That means if, according to y equals mx, if you graph force on the y-axis, and you graph m1, m2 over d squared, if you get all those numbers and do a little calculation and get a number, and you graph the force versus that big thing there, you should get a straight line. And the slope of this line, slope, should be big G. See how we took that equation and we just crammed it in there? We could have done it different. There could be another answer to this one. I could actually take the d squared and multiply it by the other side, and I could get fd squared equals big G m1, m2. And that would work also. I could do y, there's my y, equals, m, slope, which is g, times x, which would be m1, m2. So on this graph, I would have graphed fd squared on the y, and I would have graphed m1, m2 on the x, and I'd still get a straight line, and the slope would still be g. So there's a couple of different ways you could manipulate this, but in both ways, you can cram it into the y equals mx plus b and figure out how to make the slope be g. Hopefully that made a little bit of sense. Okay, so let's try to go to the next problem. Next problem, we're still using the same law. F equals big G m1, m2 over d squared. Now this time it says What would I graph on the x and what would I graph on the y? Okay, what would I graph on the x? What would I graph on the y so that I get a straight line, and the slope of that line is d squared over big G m1. What would I graph on the x and what would I graph on the y so that I'd get that? Okay, so remember y equals mx plus b. And what do I need in the slope spot? Right here in the slope spot, I need d squared over gm. So let's try to take this equation, f equals big G m1 m2 over d squared. And let's figure out how can we get somewhere in this equation a d squared over a gm. Let's do that first. Well, right now d squared is in the denominator. We need it up in the numerator. So we're going to multiply it to the other side. So fd squared equals, and then the g and the m1 are up in the numerator. We don't want the denominator, so we're going to divide that underneath. So we'll do that underneath, and that leaves us with an m2, right? Okay, and so we could do that. We just leave it just like that. So what do we got? I could flip this thing all over, so I'd have m2 equals d squared over gm times, I'm going to write it like this so you'll maybe see it, times f. Okay? Now, that fits into the y equals mx, right? Y should be your m2. M, your slope, is what we need it to be, d squared over gm times x. Y equals mx. m2 equals d squared over gm times f. So on your y-axis, you would have put the second mass 2, and on the x-axis, you would have put force. And you would get that slope. Are you understanding? Okay, you need to manipulate the equation so that I can cram it into, I can do a comparison here with it, and I can get the slope to be where I need it to be, and I can figure out what goes on the y and what goes on the x. Okay, let's do the next one's actually more simple. Using the density equation, what's the equation for density? Density equals mass over volume, right? What would I graph on the x-axis and what would I graph on the y-axis to get a slope, a straight line, and the slope is going to be density? What would I get? What would I do? Well, y equals mx, right? So I need density to be in the m spot. So I'm going to multiply, I start with density equals mass over volume. I'm going to multiply the volume by the other side and then flip it. So I'd have mass would equal density times volume. And there you go. Y equals mx. What do I put on the y? I put the mass. What do I put on the x? I put the volume. And the slope then would be density. That's a pretty easy one. Now another way to look at that is look at this. Density equals mass over volume. And we want the density to be slope. And what is slope? Slope is, right, rise over run, or y over x. So it might have been easier just to do it that way. If this is density is slope, then I know this has to be on the y and this has to be on the x. The volume has to be on the x. Rise over run. Okay, that was actually a fairly easy one. Let's look at the next one. Use the kinetic energy equation. What's that look like? Ke equals 1/2 mv squared. Okay, there's your equation. What would I graph on the x and what would I graph on the y to get a slope? A slope m equals, the slope would equal 2 over m. Probably get too many m's in here. Slope equals 2 over m. Okay? All right, so what do I got? I have I'll rewrite this. Kinetic energy equals, I can write like this, mv squared over 2, right? So what do you have there? You have an m over 2. We need a 2 over m. So I'm going to multiply the 2 over and divide the m underneath, right? So I'm going to have 2ke divided by m equals v squared. And if I flip this whole thing over, I'd have v squared equals 2 over m, I'm going to write it like this, times ke, so that hopefully you can see it. Y equals m times x. So what goes on the y? Velocity squared. What goes on the x? Kinetic energy. And the slope of this line that you would get should be 2 over m. All right, let's look at the last one. The last one's actually super easy. There's an equation to calculate the final velocity after you've been accelerating for a certain amount of time. And that equation is VF equals AT, acceleration times time, plus initial velocity. Okay, and it says if I graphed final velocity on the y-axis, VF on the y-axis, and I graphed time on the x-axis, okay, I would get a straight line, and it says, what would the slope of that line be, and what would the y-intercept be? Well, this is really easy, because look at this equation. It's already y equals mx plus b. Y equals mx plus b. If you graphed final velocity on the y, there it is, and you graph time on the x, there it is, you're going to get a straight line, and the slope of that line is going to be the acceleration. And the y-intercept right here will be your initial velocity. If your initial velocity is 0, then this equation is VF equals AT, and this is just y equals mx, and the line would be going straight through the origin. So that's how we can manipulate equations to figure out what you graph on the y and the x to get the appropriate slope that you need. Hopefully you somewhat understood that. If you didn't, you can watch this video like 100 more times.